Hi everyone, welcome back. It's great to have you here today. In this video, we are going to go through this paper together. Before we dive in, please make sure you have had a go at these questions. Okay, now let's get started. Okay, so let's first look at this question. In this question, they want us to fully factorize this expression. Now, as we can see, 2x plus 1 is a factor, although it's in the bracket, but we can take that one out. From the first term, we have 3 lots of 2x plus 1 left. And then from the second term, we have negative 9. By expanding the bracket in the squared bracket, we will have 6x plus 3. Subtracting 9, we can simplify to 6x subtract 6. Now we haven't finished here. It's because we can see 6 is a common factor in the second bracket. Therefore, we can further factorize out a 6. Therefore, our final answer is 6 bracket 2x plus 1, x subtract 1. Now, in part B, it says hence or otherwise. So if a question says hence, that means we can use what we have in part A. So as we can see, the numerator is what we have factorized in part A. In the denominator, we can factorize out 4, and that gives us x subtract 2x squared plus 1. And by using Farmer's field, we can put negative 2x squared and 1 in. Now, multiplying negative 2 and 1, we have negative 2. We have to find two numbers that multiply to give us negative 2, but add to give us 1, which is 2 and negative 1. Therefore, we can factorize our denominator to 4 bracket 2x plus 1, negative x plus 1. Now, as we can see, immediately 2x plus 1 is a common factor. 6 and 4, we can simplify it down to 3 and 2. Now, what we have is 3 lots of x subtract 1 over 2 lots of negative x plus 1. Negative x plus 1 and x subtract 1 looks very similar. What we can do here is to factorize out a negative 1 in the denominator. Therefore, we will have negative 2 lots of x subtract 1. So we can further simplify this expression into negative 3 over 2. Okay, now moving on to the second question. In this question, we are told that the nth term of a sequence is given by this expression. And it is a quadratic equation. And what we want is to find the sum of negative terms of this sequence. And we need to show clear algebraic working. Now, by guessing and check doesn't give us any mark in this question. So let's quickly sketch this quadratic. This is going to be a happy curve is because the coefficient of n squared is positive, which is 0.05. But we don't know where it is. It could be anywhere on the x-axis. So what we can do here is we know that A is 0.05, B is negative 3.2, C is 51.1. We can use quadratic formula to solve this equation and to find its root. That means the x-intercept. By putting these values back into calculator, we can work out that x is 30.59 or x is 33.41. So any values between 30.59, 33.41 will give us negative terms. This is because the graph is under the x-axis. So that means n could be 31, 32, or 33. If n is 31, by putting this into the position to term rule, we will have negative 0.05. When n is 32, we get negative 0.1. When n is 33, we will have negative 0.05. So the sum of these negative terms is negative 0.2. So moving on to the next question, question 3. We are told that the equation of a straight line 2y plus 3x equals 7. And we need to find the equation of the straight line that is perpendicular to this line and also passes through 6, negative 4. Because we know if two lines are perpendicular, their gradients are going to be negative reciprocal of each other. So what we need to do first is rearranging this equation, make y equals mx plus c. And we can see the gradient is negative 3 over 2. The gradient of the perpendicular line is going to be 2 over 3. So our equation is going to be in the form of y equals 2 over 3x plus c. Now this line passes through 6, negative 4. So we substitute this point back into the equation, and that will help us to find c, which is negative 8. Okay, so now moving on to question 4. In this question, we needed to prove that 6x squared, take away 6x, plus 10.5 is positive for all values of x. So what we need to do is we need to complete the square. First, we need to factorize out 6 from the first two terms, and we will have 6 lots of x squared subtract x, and we are going to leave that 10.5. And what we need to do now is to complete the square of what's in the bracket. So it's going to be x take away a half squared, and then further subtract a quarter. Now these square brackets are important here. It's because now we need to expand the square bracket, and we will have 6 lots of x take away a half squared, take away 3 over 2. We get this by multiplying 6 and negative a quarter, and then we add 10.5 that is outside of the bracket. And then we can simplify by collecting the constant term. We will have 6x subtract a half squared plus 9. Now because we know anything squared is going to be greater than or equal to 0 for all values of x. So no matter whether x is positive or negative, by squaring it, we'll have a positive value. Now 6 lots of positive value plus 9 will give us anything that is greater than or equal to 9, which is positive for all values of x. Therefore, we have proved this statement. Okay, now next question is about the inequalities. We are told that So buys fiction books and non-fiction books. He has a maximum of 900 to spend on these books, and the fiction books cost £1.50 each. Non-fiction books cost £2 each. If x is the number of fiction books he buys, y is the number of non-fiction books he buys, we want to show that 3x plus 4y is smaller than or equal to 1,800. Start from what we have. We know that fiction books cost £1.50, and then he buys x books. Non-fiction books cost £2 each, and he buys y books. In total, he has £900 to spend. Therefore, 1.5x plus 2y needed to be smaller than or equal to 900. By multiplying both sides by 2, we will have what's in the equation, 3x plus 4y smaller than or equal to 1,800. The second constraint is x is between 0 and 400. That means he will buy more than 0 fiction books, but fewer than or equal to 400 books. So the number of fiction books he buys will be between 0 and 400. So what we need to do now is to draw these lines and find the region that satisfies all the inequalities. So first, let's start with 3x plus 4y is smaller than or equal to 1,800. So what we can probably do to make it easier is that we rearrange to make y equals negative 3 over 4x plus 450. This is because we know how to plot this straight line. So you will pick some x value, find its y value, and you want at least 3 points to make sure they are all in a straight line. So this line we have drawn here is 3x plus 4y is 1,800. And we want 3x plus 4y to be greater than or equal to 1,800. That means anything is above this line. So we can do so by checking some points. You can substitute point 0, 0 back into the inequality and see if it's true. If it's not, you are going to shade it away. So anything above this line will be shaded away because that is not what we want. Moving on to the second inequality, x is between 0 and 400. X needs to be smaller than 400. So what we can do now is to draw the line x equals 400 and x equals 0. Now the difference here is because we are strictly greater than 0. So we need to use dashed line. We want x to be between 0 and 400. Therefore, we are going to shade greater than 400 away. Finally, we want y to be between 0 and 300. Similarly, I'm going to draw the line y equals 300 first. And we are going to draw the line y equals 0. Now, we are using dashed line here is because it's strictly greater than 0. So we don't want anything to be greater than 300. We're going to shade it away. Now, this region here is what we want. Okay, so now, So sells all the books that he buys. P is the profit he makes. From previous part, we know that these books cost him less than or equal to £900. He would have made 350x plus 650y from selling books. And because we are talking about profit here, so we are going to take away the cost from the income. And by simplifying, we will have P equals 2x plus 4.5y. And now we need to work out the maximum profit that So can make from selling all books. So what we wanted to do here are checking these points, these corner points. Point A has coordinates of 200 and 300. By substituting that back into equation we get in part D, we have 1,750. Point B has coordinates of 400 and 150. We will get 1,450 from point B. As we can see, A gives us the maximum profit. Okay, so now moving on. Question 6. This question is a little bit more complicated. So what we are given is a prism with a cross section that is a trapezium. And we are told that AB equals BC equals EH equals FG equals AD equals BC is 60. And we are also told that the area of the cross section AFED is 1,230 centimeters squared. And what we are told is that J is the midpoint of HG, M is the center of the square base ABCD. So that is where the diagonals intersect. And what we need to do now is to find the angle FMJ. Now I'm going to draw out this triangle FMJ, and this is the angle we want to find. If we have the information of all three sides, then we'll be able to use cosine rule to work out the angle. So let's first look at JF. How can we work it out? Now JF is also on the surface EHGF. I'm going to draw out this triangle JGF. And then this length here is what we are looking for. Now we know FG is 60. Now we need to work out JG. So what we can do here, we can draw a line across. We can split this trapezium into two parts. One is the rectangle underneath and one is the triangle. I'm going to draw out the triangle here, which is GHK. And we know GK is 60. We don't know HK, but we can work it out because we know this trapezium has an area of 1,230, and we know the base is 8, the height is 80. By using the area formula for a trapezium, we can work out the length of ED. By substituting the values, we can work out that ED is 33. So that means HC is also 33. Now, if HC is 33, KC is 8 because it's a rectangle, then we can work out HK is 25. By using Pythagoras theorem, we can work out HG is 65. JG is a half of HG, which is a half of 65. Therefore, we can work out JF by using Pythagoras theorem as well. We have now worked out FJ. Now moving on to JM. How can we work out JM? We can also make a right-angled triangle JMH by drawing a perpendicular line from J to BC. And I'm going to draw out this black triangle so that we can see better. JPM is this right angle triangle, and we need to work out JM. MP is a half of AB. It's because J is the midpoint of HG. When we draw a perpendicular line from J to BC, we will find the midpoint of BC, which is P. So we know AB is 60, therefore a half of AB is going to be 30. Now how can we work out JP here? Let's look at this triangle just above the rectangle. The triangle HJK, so as we can see, there is a pair of similar triangles. Because we know J is the midpoint, the scale factor from the larger triangle, JHK, to the smaller one is a half. Base of this small triangle, which I should really name this point here, which is 25/2. So we know this distance here is 8 because it's a rectangle. So what we have in total is this JP is going to be 41/2. So by using Pythagoras theorem, we can also work out JM, which is 36.3352. So what we need to do now is MF. If we look at this 3D shape, we can see this MFA is also a rectangle triangle. It's because FA is perpendicular to the base. Therefore, the angle MAF is 90 degrees. We know AF is 8. We know AM is a half of AC because M is the midpoint of the base. So to work out AC, we can see this triangle ADC, which is 60 and 60, isosceles right-angled triangle. By using Pythagoras theorem, we can work out AC to be 60√2. Therefore, AM, which is a half of AC, is now going to be 30√2. By using Pythagoras theorem, we can work out MF to be 2 square root of 466. So now in this triangle, MFJ, we have all the sides Now we can use cosine rule to work out the angle. We know JF is 5 root 745 over 2. We know JM is 36.3352. We know MF is 2 root 466. By substitute these values back into our formula and then rearrange for cosine JMF, we can work out the angle JMF, which is 117.9 degrees. Okay, so now moving on to the next question. We are told that there are green, blue, and red sweets, and there are 12 green sweets. The number of blue sweets is twice the number of red sweets. If the number of red sweets is x, the number of blue sweets is going to be 2x. And we are taking 2 sweets out of the jar. We are told that if both sweets are green, the probability is 22 over 925. And now we need to work out the probability that one sweet is blue and one sweet is red. So what we need to do is to work out the total number of sweets. And that is 12 plus 3x. By drawing a tree diagram, the probability of this first sweet is green is going to be 12 out of 12 plus 3x. The probability for picking blue is going to be 2x over 12 plus 3x. And then the probability for the red is going to be x over 12 plus 3x. Now we are taking 2 green sweets. So that means the second sweet is also green. Then that means there is only 11 green sweets left in the bag. And then the total number of sweets is going to be 1 less because I've already taken out a green sweet. So probability of green and green is going to be 12 over 12 plus 3x times 11 over 11 plus 3x. And we know this probability equals 22 over 925. So what we need to do now is to solve for x. First, I'm going to multiply the left-hand side together, and I'm going to multiply both sides by the denominator to get rid of the denominator. What I'm going to do next is cross-multiply. So we have 132 times 925 is equal to 22 lots of 12 plus 3x, 11 plus 3x. By simplifying and expanding the brackets using Farmer's field, we have the quadratic equation 9x squared plus 69x plus 132 is 5,550. By rearranging, make one side equal to 0 and dividing both sides by 3 to simplify this quadratic equation, we have a is 3, b is 23, c is negative 1,806. So by using quadratic formula, we can solve for x. X is 21 or negative 86 over 3. Now x is the number of sweets, so it can't be a negative number, so x is 21. Therefore, we know the total number of sweets is 12 plus 21 plus 2 lots of 21. That's the number of blue sweets, and that is 75. So this is all the information we have. We know there are 12 green sweets, 42 blue sweets, and 21 red sweets. Now we want to work out the probability of getting 1 blue and 1 red. So the probability of getting first blue sweet is 42 over 75. Because I picked out 1 sweet already, there will be 74 sweets left. The probability of getting a red, given that the first one is blue, is going to be 21. The probability of getting a second blue, given that the first one is red, is going to be 42. So what I needed to do now is to work out the probability of getting blue and red. So what we needed to do is to multiply the probabilities along the branch. It's because for both of them to happen, the probability is going to be smaller. So we are multiplying 2 fractions together. There are 2 different ways of getting blue-red. We can get a blue first and then red, or red first and then the blue. We are going to add these 2 probabilities together, and then we can work out that the probability is going to be 294 over 925. That's it for today. Well done for making it through to the end, especially if you have done the questions yourself. Remember, maths isn't a spectator sport, and we have to keep practicing to be more fluent. Happy revising, and I'll see you in the next video.